13849 Southwest Carl Brown Drive.
In the UK and New Jersey. And he was probably frustrated with the kind of oscilloscope he had to work with then. So when the war ended, he joined up with Jack Murdoch, who had been in came out in 1947, which was the year I was born.
Separate power supply?
No.
Oh, no, it's a calibrator.
This is a calibrator. This was actually the first product they manufactured. They needed something to calibrate the scopes with, and also they thought they could sell something and make some cash to help finance the design of the oscilloscope. So they built 10 of these, and this is actually the very first one, we think. It's November 46, number 1, because we know there's a number 5, which is a guy down in the Bay Area owns it. So they built 10 of these, offered them for sale, nobody bought them. The reason was nobody needed. This was to calibrate an oscilloscope that didn't exist yet. Mm-hmm. So nobody needed them. So they used them internally, but they got some experience building stuff. And then Howard designed the 511.
These things are a lot of fun just to look at from an aesthetic standpoint.
CRTs. And they were all glass for many years. They had to purchase the glass from a company in Lancaster, Pennsylvania. And each time they had a new shape or to do, they had to go through an engine charge, setup charge, and all that, and the delay to start up a new design. They just stock glass for that, but they could make whatever shape they wanted, and they could do it rather quickly. And that was done in this building. This was the ceramics building. All strips that were a famous part of their construction. This was, this is a 545, a standard, pretty much popular lab scope. They had the kiln, they had expertise in ceramics, and nothing to do with it. And that's when somebody decided, let's start making the ceramic CRT funnels. So they shifted from strips to CRTs. Once it warms up, you push the seek buttons and it'll automatically set the sweep and the gain. So it's like the auto set button on your Siglent.
Mm-hmm.
This was back in the 60s though. And this is a programmer. You can dial in different sweep speeds and sensitivities. So this was like for production testing. An operator could just, instead of having to flip the knobs, could just select a particular setup. Clamshell open right now. Mm-hmm. That was the standard service scope for IBM. IBM customer engineers would carry those into the customer's site and use them to fix their computers. All in bigger computer centers, like I went to Caltech, and in the Caltech Computer Center, sitting in the corner was an IBM-owned Tech 545, just sitting there in case they needed it. IBM would just leave a Tech 360 series in '64. They needed something a lot more powerful, so they came to Tech, and
this was the IBM Scope Project Killer, huh?
Well, yeah. This became again the standard IBM service scope for many years. And it has a metal cover for protection, and it had to fit under an airline seat so that their CEs could take it on trips. And reducing the size of the front panel of the 545, reducing all that functionality to this size. Etched on the front panel. And it was 50-50, which was very unusual at the time because the Japanese government did not permit anything but minority ownership. So getting up to 50% took special permission. And this scope was made in Japan by Sony Tech. And this spectrum analyzer was made here in Beaverton. And this pair, you can get hardware to link these two together. They're both can be battery powered. So this was a portable spectrum analyzer, 500 megahertz capability, and a lot of this package was bought by cable TV companies. Hewlett Packard eventually won, but and this has an unusual display. It's what's called a liquid crystal color shutter. There's a monochrome CRT behind it, kind of actually a pinkish white phosphor, and it's alternately switching between red and green images, and this shutter is switching between, is a filter between red and green. So your eye combines the two. When it's both, it's yellow. We don't see any red on here, but so there's a blue peak, green peak, and a red peak because there's blue, green, and red LEDs in here.
So the photometer is in there.
The photometer is here, in here.
Right,
and
looking at the bulb.
Yeah, and it's part of it. Part of the electronics are here, and part of it, the optics are in here, and the electronics are in this plug-in. And it shows spectrum changes in real time, which at the time hardly anybody else could do. Optical spectrum analyzer or spectrophotometer at that time just consisted of a diffraction grating. You rotate manually, to dial up the wavelength. Whereas this is a diffraction grating projecting onto a special Vidicon tube, which is then scanned out to read the spectrum. Something to measure the light output of cathode ray tubes with, and they couldn't buy anything that would do the job, so they designed their own and built them and used them internally. But when customers found out about them, said, we want one of those. So a lot of products that Tech sold, non-oscilloscope products, were developed internally and then became products when customers found out about them.
So a time domain reflectometer then, right? Is what,
yeah. It's sending a real narrow pulse like that, and when it reaches the end of the cable, if it's terminated right, no problem, but if it's not, it reflects back. So you can tell that's an open termination.
Mm-hmm.
If I can force a short would go down, that would be a short, and hook it up to the longer cable. Now we can dial out here, so that's 0 distance. Can dial out here, and I can read off 58 feet. And the fact that it's sloping up means it's a lossy cable. It would be sharper if it were a better cable. And so you can tell the length of the cable, but also you see some point along here about 5.5 feet. Well, this little connector is causing a glitch. So you can look along the length of a cable and see any anomalies, shorts, leakage, opens obviously, but so this is used by telephone company, cable company, and also aircraft to have miles of cable running up and down them.
And then you've got the little built-in printer as well.
So you can give a hard copy, and this is in terms of distance.
So the museum itself, is this in any way a function of Tektronix, or is it a strictly separate organization?
We're a separate 501c3 corporation. We receive in-kind support from Tektronix in the form of a space, but we're technically separate, legally separate from Tektronix. We provide some services back to them. They send new employees through here for orientation. Tech didn't invent, but they perfected storage technology, and computer manufacturers were buying 564s to use as displays. There's a DEC model that has a 564 in a rack. It's disguised, but it's obviously it's a cannibalized 564. So Tech started selling in the 60s. It was late 60s. They came up with an 11-inch version of this, and this is the tube that's in it. I don't even know how storage works.
As far as CRT storage?
phosphor screen, but behind the phosphor screen is another screen, essentially, that's charged. And the CRT has, I think it's at least 4 flood guns. They're sending electrons at about 300 volts energy toward the screen. But they don't reach the phosphor because the screen behind it is charged and it repels them. So there's a writing gun, and the writing gun is electromagnetically deflected. The writing gun essentially punches a hole in that screen behind and allows the flood gun electrons to come through. So it's like screen printing, where the ink is the flood guns and the screen, is behind whatever the surface you're gonna print onto. And when this came out in the 60s, you could build a computer display relatively cheaply compared to any other technology. At that time, raster scan or refresh was expensive because the monitors were very expensive for high resolution, and memory was very expensive. So Tech was able to produce a terminal for $5,000 when the competition was $50,000 on up. So in the 60s and 70s, they just owned the graphics market. It just dominated the graphics market. And even after that, when these terminals were phased out, the replacements had to emulate, the software at least, they had to accept the same commands, to draw the same pictures. So, and there's still computer manufacturers, they were selling these to computer manufacturers who were using them and making terminals with them and using these displays. And they said, well, why don't we build a terminal? So they took one, put a fancy bezel around it like that, added a keyboard and electronics to create a terminal. So this was the first Tech terminal. They created a lot of, this is a 11-inch, they had 19-inch and 25-inch terminals. But they took this display and added a microprocessor. So you would know what a 6800 was. And then the storage mechanism is this tape, but these tapes have all gone south. The plastic band that's around here is deteriorated, and we found some replacements with that. So one of our volunteers, this thing has these plug-in RAM packs. They're like game cartridges, ROM packs they call them. He created what he calls a RAM pack. It's technically a flash memory. So we were able to recover games and data from a bunch of tapes and load them in there. So this is programmed in BASIC, and it's a Kemeny BASIC. It's not the stupid Microsoft abortion. Where every new command they come up with a new syntax. So this came out in '75. That's when everybody was building their own, starting to build. I was starting to build a computer. I used to MOS Technology 6502 because I liked it better than the 6800. Not bad. I liked the 6502 architecture better because of all the index. Essentially, it had a bunch of index registers. So I started building my own system around a 6502, and I started with just a chip and glue logic, and then I bought a Kim 1. So a little an ecology around the 6502, like there was around the 8080 and Z80. No. So ever since then, I don't buy Apple products. Never bought an Apple product. A lot of little transformers, capacitors, inductors, CRTs, and there's a building in the northwest corner that now says Maxim on it because in 1994 they sold it to Maxim, but that was Tektronix's fab. And I worked for Maxim from '99 until 2013. This is a 1930s or early 40s CRT. It might have been the kind of CRT in the oscilloscopes that Howard was using during the war.
The jitteriness?
It's it's AC from the transformer back there.
Okay. Picking something up from the transformer.
Yeah, there's no, every Tech scope has a metal shield around the CRT.
Mm-hmm.
Well, this was all open so you could see it.
Right.
It doesn't have a DAG coating like newer CRTs did either, so But it's nice to be able to see the gun and the deflection plates. And this is being driven by an Atmel processor and a Maxim D to A converter. So this is like 1930s CRT being driven by 2000s technology. Tech boards added in to do the oscilloscope function. But it's an old version of Windows that doesn't run anymore.
You said it's a clone?
A clone
By who?
by a company called Jetronic. In the 60s, well, maybe late 50s, the government and the military were not happy with the prices they had to pay Tektronix for scopes. So they contracted with 3 other companies, Jetronic, Lavoie, and Hickok, to clone the 545. Hello. Oh. So Tech sued the government starting in '61, and finally in 1979 it was settled. Took 18 years, but Tech won in the end, and a precedent was set that the government just can't, give away patents like that. But some people who owned these thought they had Tech scopes. They would call Tech service to get them repaired. Hi, Peter.
Hi, let me
Around
tell you.
$5,000. Like I said, if you wanted to buy anybody else, it would. Like IBM's was $250,000. There were $50,000 terminals. A lot of people say, "Oh, I used one of those in college." Connected to a computer via serial link. You familiar with the TM500 line?
I am not.
Oh, well, this is sort of another example of instruments that Tech initially built for internal use, but productized, and they had big, at least a dozen or more different plugins, and you could customize a test setup. The military bought a lot of these because they had a particular setup, a particular combination of instruments. It's a pulse generator. Yeah, you don't have to have a scope in there. You might have just all non-scope instruments. But they did make some of these, and this is a really nice scope for lab. I have one on my bench here.
Very elegant design.
It's at 20 megahertz, and it's really doesn't have dual sweep, but
So the same CRT as the 212 or that whole series, I guess. Yeah, that's the animal. Gosh.
in 1971, Tektronix bought a little company in the Bay Area called Sintra. They made these calculators, and these are among the most advanced calculators at the time. You might recognize those, the Ntsc tubes, these tape cartridges, and then a printer. And then Tech combined everything all in one, printer, display, and tape all in one as this Model 31. But about the time this came out was when HP came out with
The 35?
whatever it was, their first calculator,
Right.
portable calculators. So they didn't sell a lot of these. The competition was too stiff. But their entry into calculators actually was what led to the 4051 back there. It was the same group of people that, and a lot of people referred to the 4051 as a calculator. The guy I worked with, where's so-and-so? Over by the calculator. What? Oh, the 4051? But there's a story around this. Texas Instruments sued Tektronix for infringement of some IC patents. And Texas TI calculators use what's called algebraic notation, 1 plus 2, parentheses, you can do all that. And HP uses reverse Polish.
Right.
And I'm not sure if they made that, why they made that choice, but so when Texas Instruments sued Tech came back with, oh, that algebraic notation that you use on your calculators? We have a patent on that they acquired from Sintra. I said, oh, okay,
Yeah.
we'll settle. So they did
Okay.
the cross-licensing.
Right.
But it might be that patent that was why HP went and used RPN instead. I don't know. Handle 128 levels of parentheses, but I don't know how you would ever do that. You know much about wave propagation?
Some, but certainly not an expert on it.
Well, if this is a wave going down a transmission line, and then it's reflected, this is the return wave. And say the transmission line is either open or shorted because all the energy is coming back. It has what's called a reflection coefficient of 1 at the moment, or minus 1. If you do this, you see what this there would be a standing wave on the. If you could see the waves, you can see that. And since this is 0 right now, it must be a shorted termination. So I do this, I simulate an open termination. And if I change the reflection coefficient, so the less is reflected, then the standing wave pattern looks a little different. But there's still a fixed location of the peaks and the valleys, or the maximum amplitude and the minimum amplitude. It's hard to see that. Works better on a digital scope where you can do one of them was Rogers organ.
Really?
It was around 55 or something. 3 tech engineers. One was named Fred Tinker, Rogers Jenkins, and I don't remember the third guy's name. Developed a circuit they thought would make a good tone generator for electronic organs. And they brought it to Howard Wallum. He said, well, Tech isn't interested, but Howard, as it happens, was an organ enthusiast. And so he said, well, I'll help you set up a company to build organs. So that was the beginning of Rogers Organs. So that was a spin-off. And then they built electronic organs, but they also purchased pipes, and they made pipe organs and hybrid organs, mixtures. The name, well, Jenkins organs, or Tinker organs, or Fred organs. No, Rogers. They picked Rogers.
Well, it's certainly a respected name in the industry.
Well, it used to be. We have a couple of, one of our volunteers worked there. He used to do all the, his wife bought this for him from, it was shipped up from someplace in San Francisco, theater in San Francisco. And he had an outbuilding separate from his house which was an organ studio, where he had this organ. And we have a recording of his organ, played by Jonas Nordwall. Have you heard that name? It's a fairly well-known organ.
Don't know that one.
I've had the pleasure of recording him a couple of times. I have a recording. I have one of these at home. I bought on eBay. It's my favorite model. This is a little plug-in they made for 5,000. They also made for the 7,000 series plug-in. I got this one on eBay. They're pretty rare. It's just low power, and they advertise it as sort of a go-no-go tester. But this is the original transistor curve tracer, which is inside is all tubes. But before this, they made a tube curve tracer, Model 570, for doing tube testing. And that one is highly prized, and if you see one for sale, it'll be for thousands of dollars. The audio fools have bid up the price on those. 2 units were used in nuclear bomb testing. This one came out in '62. It's got 1 gigahertz bandwidth, but it's not very sensitive. It's 10 volts per centimeter. Because the signal goes in. Here there's a trigger pickoff. Then the signal goes through 40 feet, of delay line to the CRT. And the CRT has distributed deflection plates. That's actually a transmission line connected to individual segments of the deflection plates. So there's no vertical amplifier at all. But apparently they had, 10 volts was just fine. They had transducers putting out enough voltage connected to the bomb. So there'd be a bunch of these in a trailer with all the wires leading off to where the underground nuclear bomb was. And they'd fire off, photograph them with Polaroid film. And hopefully the trailer didn't get bounced. Sometimes the trailer was too close and it would get bounced, and a bunch of these would be damaged. we need a bunch of more 519s, or we need our 519s repaired. And later, it's a headless oscilloscope. In the sense that there's no display built in, but it has a special CRT. It's called a scan converter. And this is a 1 gigahertz cathode ray tube projecting its tiny image on this screen here, which is then read out by this is a Vidicon camera tube. So the image comes out as video. So they would locate these in a tunnel connected to the bottom. The blast, the signal would come down the wires, reach this. Meanwhile, the blast wave is eating up the signal. This would translate it, send it on, and the blast wave would hit it and would be sacrificed. So they sold dozens of these for every nuclear test. And no returns, no warranty issues, no long-term reliability. Don't have to work once. RM rack model 7603, something like that. And these are all cameras. The cameras are all folded out now. But somebody had to go through and load film in all hundreds of those, and occasionally they'd have a misfire, and they'd have to go back and reload all the film. Experiment.
Just to see if they could merge the glass together?
Yeah, well, I don't know. There's supposedly there's enough phosphor on here that if you fire it up, you see an image, but we haven't tried. This is this gun from one of their really small, like the 200 series CRTs. Excuse me. VintageTek Museum. Then I'll take you back in our restoration area. Oh, yeah. This is the biggest storage display they made. They didn't make they bought, it was a CRT glass from the TV tube. But then they put their own stuff in it to make the storage display. 25-inch, weighs a ton, half a ton. But when storage, the handwriting was on the wall that storage was going to be replaced by raster scan. Tech came out with a whole series of raster scan terminals. This is one that I was a designer on. It was 640 by 480 resolution, but at the time was pretty good. But your phone is like several times that. So. And during before raster scan became economical, Tech, I say they dominated the graphics market with the storage technology, but once monitors came down, memory prices came down, there were no barriers to entry to all other competitors, so Tech didn't have anywhere near the same market share as they had during the storage tube era. But they were pursuing other display technologies, and this is one. If you look at this through these glasses, once it's up, I don't like touching Apple products, but
it's a 3D.
Three-dimensional. It's like 3D TV. The left and right images are being displayed alternately, and then this screen is switching polarization from. It's either. On this, they came out in 1989, which was long before 3D TV came out. This was what they call cache of computer-aided chemistry. It was sort of like that spectrophotometer was aimed at the chemistry market. This is aimed at chemistry market, but all kinds of other design applications. You could use 3D. Mechanical designers could use 3D. But they sold this division off in '94.
Right.
So I say this. They were looking for they were grasping at straws, I think. They were looking for some technology to replace storage that would give them a lock on the market again. And they thought that this color shutter would do it. But to do, one of the last projects I worked on at Tech was a 13-inch full-color LCCS demonstration unit with the crystal color shutter. As a musician, you would certainly appreciate this. There's this guy over in, I think he's in the Netherlands, with a lot of time on his hands. And he figured out how to make music that also looked very reasonable on an oscilloscope. This is just playing the left and right channels. The speaker's playing a sum of the two. And this wave files, this is a little, you can buy these on eBay for $2. Little board. It takes an SD micro card. It'll play wave files and MP3 files. And you notice the more detailed the picture is, there's more high frequency energy in the sound. Somebody said it looks like a marijuana leaf. Because maybe that's what the guy was on when he did this. He calls those mushrooms. Files has a bicyclist in mountainous territory, mountains going by, and a bicyclist on the screen. Professor Gertrude Remfer at Portland State University, who was developing an electron microscope and joined up with Tech in order to try to productize it. An electron microscope is just a big cathode ray tube. Shoots a beam of electrons and through a sample onto a screen. So Tech had all the expertise that was needed to do that. So, but they were going to productize it, but Tech lost interest and ended up spinning it off in a little company called Electros. And we get very conflicting reports as to whether Electros actually sold any instruments. In fact, the guy that just called me this one, Electros. But a guy we had just recently, just last week, somebody called up and offered us. He said it was unit number 57, so they must have sold several dozen of them. There's a special frame buffer that they built, which I said cost $50,000 at the time. It's only 512 by 512 by 24. But this was when Tech was doing research into other kinds of technologies. One of the things they were trying to do was, if you have a raster display, you have finite points where you can place pixels. So you have what look like jaggies in the lines. The storage displays. In fact, see if we can turn this on. They have vector generators that draw precisely from point A to point B with no jaggies. They draw straight lines. So when they started to replace the storage displays with raster displays, people complained about the jagged lines. So they were doing various things to try to do that. One thing is that you can vary the intensity of the pixels to sort of position them, so essentially between two pixels by half illuminating the 2 pixels. That was called anti-aliasing. But it produces a blurrier display, and was never. The solution was just to go to higher resolution than that. We decided, since we got the 14-inch or the 19-inch running, this is now surplus. We're going to give this to Paul Allen's museum. And these are the three, basically the trio: the timing generator, the sine wave generator, and the calibration amplitude generator. This is what you use, the standard calibration suite for scopes. And I'm accumulating. I specialize in restoring 465s and 475s. I'm accumulating a collection that we're going to have for a lending library so kids can borrow scopes. Well, I haven't shown you the TV instruments up there. This scope was built as part of a class back in the 50s. And we don't know the whole story, but there's a guy that was supposedly involved with it. They decided to just design and build a scope as part of the class as a learning experience, and eventually some of the circuitry made it into an actual tech scope. The model, actually, probably the Model 315 is very similar to this. They're working, they're awaiting restoration. And here's 3 curve tracers. One of them, we know it works. The other 2 are parts units. But we occasionally, when we can sell stuff, but some of the big stuff is so hard to pack, so it's a hassle to sell. And we have a whole rack of 400 series instruments of various stages back there, waiting restoration. So somebody had accumulated these and gave us this whole collection. Then we have a whole bunch of cathode ray tubes.
Wow. This is Tektronix heaven right here.
We're turning away donations.
Yeah.
If anybody donates a 561, I've been turning it away because we just don't have space and or the labor to ever do anything.
Yeah.
Like somebody just gave us this whole collection of, these are 200 series CRTs,
Mm-hmm.
but a lot of these were prototypes or experiments or rejects. There's a couple of good tubes in there. We have a stock of replacement tubes. We have a whole bunch of other parts. Some poles, but a lot of unused new in box type parts. And a whole bunch of semiconductors. Sort of a
Proprietary ones?
Well, no. Well, most of them are industry standard,
Mm-hmm.
but these are they be tech part number marked.
I see.
But these were all purchased semiconductors. Then we have some ICs. Some of these are tech-made ICs. No, not those. Where are they? Nope, those are purchased. But we have a bunch of tech-made ICs. These are tech-made ICs. This is an amplifier chip that's used in a lot of scopes.
Physically, it looks like what the 212 I have is based on. That whole thing seems to have about 8 op amps in it and 2 packages, and they appear to be proprietary.
70s. Tektronix owned the TV test equipment market. If you went into a TV studio any place in this country or a lot of other countries, you would have found a rack of tech equipment. And there are oscilloscopes. Well, this was the first scope, 50s, that was intended for TV. It just had a special sync separator, I think, and then they came out with this model specifically for television waveform monitoring. And then when color television was starting to be developed, they came out with this vector scope. And that, you know how color television, Ntsc, worked. The color is represented by a 3.58 megahertz subcarrier. That's white, no color. But then there's yellow, cyan, green, magenta, red, blue. And the intensity of the color is by the amplitude of the subcarrier. And the actual color is the phase of the subcarrier. So right here there's this blivet where it's switching from one phase to another. That's this transition from green to magenta. So, but this doesn't tell you very much about the color. This vector scope actually decodes the phase of each of the color subcarrier signals. So each of those color bars is one of those points, and the points had better fall in their little boxes for all the phases to be right, the amplitudes. So this is a later one, but this was the first. This is tube-based vector scope that Tech produced, and when RCA was just developing color television, and we sold a number of them to RCA. And then they didn't hear anything from RCA for months and months. No more orders, new orders or anything. And they got back to RCA and said, what's going on? They said, well, your vector scope showed how bad our equipment was working. We went back to the drawing board and redesigned it, and then came out, with a new design and bought a whole bunch more vector scopes. And Tech was, they're already in black and white TV, and then they added the color test equipment, a real Emmy.
Wow. And is that two Tektronix?
Yes. This was awarded in 1983 for outstanding achievement in engineering development. They did the work for color in the 60s, but were finally recognized in the 80s. And they were given several Emmys for. But you would never see these on the regular Emmy show on TV. These were the technical Emmys, and they were cameras and stuff. So Tektronix bought Grass Valley and owned it for a number of years. This was in Grass Valley, California, which is down near Reno. Then they sold that off. But in the Star Wars movie where Darth Vader gives the order to fire the Death Star, Death Ray thing, the guy does this. It's one of these.
Oh, yeah.
So if you ever watch the movie again, you'll see it's that. In the movie 2001, Space Odyssey, there's one scene where they were probing. This is the AE-35 unit. Hal says the AE-35 unit is going to fail. So the guy goes and pulls it out, brings it into the lab, and they're probing it, testing it, and they're using a Tech probe. And of course they didn't find anything wrong, and then things got a lot worse from then on.
Is this the one that was the Sony?
No, nope. These are all Tech made. This is a Sony Tech.
That's the Sony Tech.
And that one over the 323 is a Sony Tech. There were several Sony Tech scopes, storage and non-storage. Some of them had Tech-made CRTs, and some had Sony-made CRTs.
Do you know? I think you touched on before, but the reason why the two companies wanted to work together?
Well, I think each company. Tektronix was highly respected in Japan because they were already using Tech's equipment over there. Sony was a respected company. I think that Howard and who's the Sony, the guy that started Sony? His name is Morita or something. Anyway, he met the guys and they formed a relationship and started up this joint venture. Partly because to get Tech into the Japanese market was closed, and to get Tech to sell anything in the Japanese market, they had to have this joint venture over there. They also, in order to get into the European Economic Community, started a plant in Guernsey, the Channel Islands, and they also bought a UK company called Telequipment. And they had a plant in Heerenveen in the Netherlands. So Tech it's still a global company. There's still a Tech Japan, not Sony Tech. It's now all wholly owned subsidiary. And I don't think they have any manufacturing in any European countries, but they still market worldwide. DVM with a lot of digital stuff. I don't know if it has signature analysis in it, something similar to that. But this was requested by Burroughs to service Burroughs computers. It was built originally wait a minute, not this one. There's a similar one in the same thing, 835, I think. This is a communications tester, but anyway, these are not some non-oscilloscope testers. Oh, here it is right there. This thing. 851. The scopeless scope, or the tubeless scope. So Burroughs bought a bunch, but I think the rest of the industry didn't. I don't think it was terribly successful. HP was selling a competitive, which they call a signature analysis machine, which was going to be a big thing, but the one I showed you, it's over there with the microprocessor built in. This has a special tube that's called a microchannel plate CRT, and we've got one over here. The scope at the door is a 1 gigahertz scope, but no vertical amplifier. The signal goes directly to the plates. This is a 1 gigahertz scope, but it has amplifiers, so it has sensitivity down to 10 millivolts or something per division. And it uses a special CRT, which behind behind the phosphor screen is this, right in that plane there, it's hard to see. So it's called a microchannel plate. And it has openings. The plate is made by another company. Tech invented it, but they don't. Another company had fabbed these plates. When the electron hits this, there's secondary emission, bounces off, and eventually, for every electron going in, there's thousands of electrons going out. So it amplifies. For a certain beam current, you get a much higher intensity. And it's like photomultiplier tubes, which they have multiple what they call dinodes, where the electrons bounce off and through secondary emission that's amplified. Well, this could do, in order, because that very high intensity, effectively, because of the microchannel plate amplification, this can do one-shot, nanosecond type things, like the one in the front. But the plates which are distributed, there's actually a transmission line. The signal goes down here. Some people say as the electron beam moves, electrons move down, the signal goes down, so that you get much better deflection sensitivity. This also has distributed horizontal plates because of the high-speed sweep. And then it has these lenses that magnify the image so that you get better sensitivity. Another thing that Tech pioneered was CRTs with spiral This is, the coating here starts at about, near ground, and then out here it might be 10,000 volts. And then this is a spiral, and it's a big resistor. So the field gradually builds up through here, so that whatever size image is back here, it's magnified by the time it reaches the front. So this increases the deflection sensitivity. This is called spiral PDA, or spiral post-deflection acceleration. But later on, they use those called quadrupole lenses or box lenses to expand the beam. And another thing they did too was, I don't know if they have one here, a mesh scan expansion. Right where at the end of the gun, there'd be a very thin, a mesh, which is micro machined with a bunch of little holes in it. And it was conducting, and then in combination with the dome shape of the mesh and the rest of the coating out here, made an electric field that expanded the beam. So it's called mesh scan expansion.
So the tour is concluded, but a new tour is starting, and I'm just going to do another sweep through here. A whole collection of different scope probes of basic and specialized types. Medical monitoring. And it was pointed out before, this is like a TV studio controller that Tech owned for a while. And this is all the stuff that was made and used by TV broadcasters.
We're mostly analog.
Yeah. Were there museums like this back then? I wish I knew a little bit about Oh, yeah.
This is simulation. The way it goes over here. All the the simulator is short.
I had a scope that was very similar to this in the 560 series, but I believe mine was a 564. These items are for sale, actually. Museum purchase only. Prices as marked. It's kind of funny. It's exactly the same model of Gold Star I have now, the 20 megahertz OS 7020A that I'm replacing with a reconditioned Tech scope. I also used this model of BK Precision in the past. Remember it well.
One of the things that Tech, I don't know if you've ever seen it. Well, you have digital storage, so this is an analog. It's an analog scope that you can store in the screen. And this has a split screen, so you can store on the top and the bottom. You can store it until you erase it. Now you have a digital scope that stores digital. But in the 60s, the way to record it was to photograph it with a camera or store it on the screen. So this particular tube, stripped down version, this was used by a lot of computer manufacturers. There's a model.
My new reconditioned Tech scope is very similar to this model, but it doesn't have the built-in frequency counter multimeter functions. Otherwise, it's very similar.
Well, this large screen version, or larger. The advantage of storage is that once you draw the image, it stays until you erase it.
Yeah.
The alternative, the other way of displaying is to continually refresh the display. With a regular TV, display just display over. But in the 60s, storage was a lot cheaper, just because the refresh display.
We had Type 422s in one of the colleges I attended, so I have some experience with that model.
This is really low-cost display technology. It's actually $5,000 competition, $50,000.
And I have a model 212, which is the dual trace version of this scope. I have a YouTube video on that.
And they combine the display with a microprocessor with a personal computer. 1975, this is one of the first personal computers. About $5,000. Not very many phones. Is this that? That was the first one. But this is very high resolution, 1,000 pixels, 800 pixels. Well, you have, I'm kind of skipping around. This was the largest graphics card, 25 inch. This has a resolution of 4,000 points. And it came out in the late 70s. And now we have 4K television. 4,000 points, 40. And the tech, I mean, a lot of, that's not an oscilloscope, specialized, you call it. They made some specialized oscilloscopes. This is a spectrum analyzer. It's scanning a whole bunch of frequencies.
This is a model that I used to own, but with different amplifiers in the horizontal and vertical.
And this is another specialized kind of scope called TDR. See, it sends a pulse down the cable. It looks like but also in between it, so the neck right here is about 5 So you can see how long the cable is, but you can also see if there's a little bit. Some companies use this, cable companies use that. And they use it to test all the wires under the aircraft.
Used to work in a company that actually send the robots to the bottom of the sea doing it's RBO, it's called remote operated vehicle. I think they ship the cable on cable and we actually send the one handheld meters on one side, connect the handheld meters on the other side, send the signal back and check the condition. That's what I
Maybe that was just resistance. This
doesn't
exactly. So this is the spectrum analyzer. It's scanning the radio spectrum. This is another portable one. This scope is made by Joint Motion 7. Well, this is a spectrum analyzer for light.